Thank you all so much for taking the time to join us today. You're here for a presentation on the Orange County stormwater tools, building a living model, quantifying stormwater capture and pollutant load reduction directly from your water quality asset inventory. The presenters today are Eric Rademacher with Orange County Public Works, Austin Orr with Geosyntec Consultants, and myself, John Burns with Sitka Technology Group. For the demonstration today, we'll go through maybe the first 20 minutes or so will be a PowerPoint presentation where we wanted to give you an overview of the background of the tools, and then we'll move into a live demo followed by a Q&A. For the presenters today, Eric Rademacher is an environmental scientist who graduated from the University of California in Irvine with his bachelor's in chemical engineering and another in material science and engineering. Eric began his journey in the environmental field as an industrial environmental consultant, and now in his current role with Orange County Public Works, he's responsible for data analysis and reporting for several programs under the South Orange County Water Quality Improvement Plan. Austin Orr with Geosyntec is a stormwater resource engineer and he spent most of his consulting career working with Bay Area and Southern California municipalities. He's also passionate about programming and software development and has designed and developed multiple stormwater modeling tools. And then I'm John Burns, a project manager with Sitka Technology Group, and I have a background in computer science and civil and environmental engineering. Before coming to Sitka Technology Group, I was a stormwater engineer and planner with the City of Portland Bureau of Environmental Services. And shout out to my friends at BES who are at the webinar today. I also wanted to acknowledge the key contributors, Cindy Rivers and Grant Sharp, leadership with Orange County Public Works, Justin Gruhl, key data manager with Orange County Survey, and then Aaron Pereski and Jamie Feldman with Geosyntec. Aaron's on the call today and will be available to answer any questions that may come up. And then my collaborators, Kathleen Elmquist and Nick Padina at Sitka Technology Group. So with that, our agenda for today, a little bit of background on the program in Orange County that we are supporting with this technology. Eric will lead that piece. We'll go through some features and functionality of this technology that we're sharing today. Austin will lead an online demo of the modeling module. Eric will talk a little bit about the permittee experience using the tool, and then we'll hold some time at the end for a Q&A. So one thing we wanted to emphasize with this technology is that we are trying to build an open source technology community. We are interested in building software that can be funded in one location and then made available to others, kind of taking the public dollars that are invested in this technology and expanding the public good through a technology sharing community. The platform that we're focusing on today, the Orange County Stormwater Tools, comes out of a platform that we built in Lake Tahoe, part of the Lake Tahoe Info platform. And shout out to my friends in the Tahoe region who are on the call today. So the stormwater tools were built in Lake Tahoe as part of the Lake Clarity Crediting Program to track BMP performance assessment and to come up with a means to track improvements to lake clarity by regularly assessing BMPs and then calculating the performance in terms of load reduction based on the condition of the BMPs. The Lake Tahoe community had the idea to make this technology available to others in a kind of license-free model and placed an open source license on the technology. And Sitka has ran with that, collaborating with Geosyntec to bring the Lake Tahoe technology to the Orange County region. In the Tahoe, through the Tahoe Regional Planning Agency and Orange County Public Works, there's continued funding being applied to these tools to build out the technology. And part of the reason we're hosting this webinar today is to make folks aware that this platform exists and hopefully to expand the community of co-benefit that comes from this shared technology and shared investment approach. So I'm going to turn it over to Eric to talk about the Orange County Public Works background with the tool. Hey there, Eric. unmute. I wonder if I need to unmute you.
Hello, now is my audio working?
We can hear you now, Eric. Thanks.
Great. Yeah, so I'd like to start off with an introduction to our Orange County Stormwater Program. The County of Orange is split between 2 regional water boards. So in North County, we are permitted under the Santa Ana Regional Water Board, and in South County, we're permitted under the San Diego Regional Water Board. For both permits, the county acts as the lead permittee, and we are partnered with 34 cities and the Orange County Flood Control District as co-permittees. And as you can imagine, that leads to some pretty wide, varied regulatory requirements, and we've got a lot of input from a lot of stakeholders, and a lot of different interests to consider. Next slide. So traditionally, as I mentioned, we've got kind of 2 separate permits with separate requirements. So our tools have always been developed to satisfy one specific program for a permit, or one specific type of program across both permits. And we started to realize there's a lot of overlap between the data in each of our workflows and being shared amongst our tools. But the tools weren't designed to function well together. Overall, in South Orange County, we're working towards compliance with our 2018 Water Quality Improvement Plan. That's a 30-year plan designed to help us meet some of our water quality goals. And in North County, they're kind of holding tight, meeting current permit requirements with an eye towards their upcoming permit renewal. So when we're looking at some kind of new tools that we'd like to put together, we realized we really need something very adaptable and modular so that we could work with both the current South requirements and the planned upcoming North requirements. And next slide. So our decision to adopt the Stormwater Tools platform from Lake Tahoe and modify it for Orange County was really born from a desire to bring a lot of our different tools and workflows and knowledge bases together. We started by evaluating what we knew, and we identified that on one hand, we had a really robust knowledge set with our structural inventories, our geographic data and our physical location information. And then we also had a lot of information from our inspection and operations departments. So we had a lot of information on conditions of our BMPs and how things were actually operating in the field. And then we had a third knowledge base for a lot of our kind of technical and design information. And we kind of realized that all of this was great information, but it wasn't really meshing together to provide any kind of deep, program-wide benefit. So we went through, we decided as we were looking into different tools, we wanted a way to bring all of our skills and all of our different workflows together into one tool to help us collaborate a little bit better using our existing skills and data sets. And with that, I'm going to pass it over to John to talk about the features and functionality.
Thanks for the overview there, Eric. Just going to make sure I can see the Q&A screen in case any of those come up. Feel free to use the Q&A feature in Zoom if you do have any questions to the audience. So as we set out to develop this platform, we wanted to adhere to certain principles. Number one is, use what you've got where it works. Don't reinvent the wheel. So we took a look at the requirements in Orange County at the RFP phase of the project, Sitka and Geosyntec, and said the requirements for condition assessment and asset inventory are very similar to what's going on in Lake Tahoe. So let's propose to leverage that. We know in this day and age, having a web-based tool to enable collaboration and support work both at the desktop and in the field is really the preferred direction for these types of collaborative data sharing platforms. And then we wanted to get momentum and get value in the hands of the users as quickly as possible, kind of bringing over the asset inventory and condition assessment functionality and getting that up and running right away as we work to build out the modeling and quantifying benefit components, which we're going to take more time. And then we wanted to stick to this model of making the technology available to anyone who wants to use it, as these are publicly funded investments that are oftentimes siloed to the funding base that creates the work and not frequently shared more broadly. And we see common challenges with common solutions and are looking to share knowledge and share patterns across agencies to pool resources and ultimately drive down the cost to receive the benefits of these types of platforms. So starting with a modular component, we have built out initially the inventory module for determining the location and type of structural BMPs that exist, identifying the regulated land development projects, are called water quality management plans, or WQMPs in the Orange County vernacular, in the South County permit language, but you could just think of these as parcel-based BMPs, and then the inspection and maintenance logs tracked through the inventory module. And then we added the ability to manage your delineation, the water that's draining to your assets, either directly through the web interface or by uploading or importing delineations that are maintained externally, for example, in ArcGIS, and implemented some tracing functionality to walk through your stormwater network and see how assets connect to each other and how the water flows through the system. And then we built on what we call the trash module to comply with the California trash regulations, which includes workflows for on-land visual trash assessments, OVTAs, assessment of priority and alternate land uses under the California trash regulations, and then some interactive map dashboards to track progress towards trash reduction goals. And then most recently, we have built out the modeling module, including the modeling parameters and inputs, web-based calculation engine, and summary reports for calculating water quantity and quality, load reduction, and volume estimates live within the platform. I'll walk through each of these modules, starting with the inventory module. We'll go through some slides just to set the context of these tools, and then we'll move on to the interactive demo. So within the inventory module, you can choose what type of BMPs you have and want to record in the tool. The definition of the BMPs can be defined by an administrator in the platform up front, and then you would inventory your BMPs and assign them to a specific BMP type. You can choose which assessment factors matter to you when you're prioritizing your assessed BMPs. There's maintenance tracking and the ability to upload design and O&M documents and to track funding. There's a data entry, and here's an example of the data entry and mitigation for a structural BMP with forms where we show the permittee experience. The foundation of this is web-based data entry. It's very clean interface, and it identifies both required and optional inputs. And as you might guess, standardizing your data here is key. Coming in, the permittees, Eric mentioned there's 34 co-permittees having data in many forms, paper forms, GIS, spreadsheets. So we needed to provide a lot of data migration options to bring existing data into the system and kind of match this format. Once the existing legacy data is loaded, the data can be largely managed either within the tool through forms like this one or through periodically uploading and syncing your external data sets. So we have a bulk uploader, for example, to allow bringing in a spreadsheet of parameters and really wanting to make the transition into this online platform as easy as possible. And then we had, for the field assessment components, the field workflows for inventory enhancement, visual assessment, and maintenance tracking. Need to support a wide variety of workflows for the different user roles, working in both the desktop and in the field, and allowing both internal agency staff and contractors to upload their BMP assessments. The field workflow includes options to update inventory information, such as the BMP ID, the location, to visually inspect the BMP, and to record maintenance activities. Then from the maintenance and inspection information, we're able to calculate an assessment score, a rapid assessment score based on visual observations and set benchmarking thresholds and weights for each parameter. So for example, in this case, looking at this particular type of BMP, in the field, you would observe the condition of the inlet and outlet, whether the device is operating, if there's any nuisance conditions, and then these are kind of yes, no type observations, and then a quantitative assessment of how much material is accumulating within the BMP. From these parameters, the module will calculate an overall condition score from 1 to 5 that can be used to weight the effectiveness of this BMP at performing its function to reduce load. And this is helpful to allow prioritizing permittee responses to when does a BMP need to be maintained and how much load reduction might this BMP be including. So that was kind of a quick overview of the inventory module. Next, we have a delineation map and workflows. This is a web-based view to visualize your network, your sub-basin network. In this case, the network is maintained by the OC survey department and then synchronized into the platform through web services. This defines the overall drainage patterns to both what we call centralized BMPs and to the distributed BMPs. The centralized BMPs are those that cover wide regions and kind of think of it as area-based treatment, and then the distributed smaller scale BMPs. The drainage areas to a BMP can be managed in several different ways. You can delineate within the web application by drawing a polygon of the delineation area. You can upload a list of catchments that are maintained within ArcGIS, or there's functionality to automatically calculate your delineation by tracing upstream from your digital elevation model. Different permittees are starting from different places. If you've been maintaining your asset inventory in GIS for a long time, you're not going to want to redo that. So a lot of permittees like to just upload their existing delineation inventory and continue to maintain it externally, typically in ArcGIS. If you're starting from scratch and you don't have your delineations well defined, relying on the auto delineation through the DEM, digital elevation model trace, is a great way to get started and have your delineations built up front. And then over time, as you're adding new BMPs or potentially in the future planning scenarios for future BMPs, you might be satisfied just drawing them in the tool by placing vertices on the map. And then lastly, the WQMP, or the parcel-based development. These are new development and redevelopment that may have multiple BMPs on a site. In the map here, you can see where rather than necessarily tracking every individual catch basin or downspout within a private development, which would be hard to inventory and may not be necessary, we can simply identify the parcels that have a control and capture the relevant parameters at the parcel level. Next, I'll talk about the trash module, which was the module that was built for track permittee progress towards Orange County's trash requirements. The trash module utilizes reference information provided by the jurisdiction, the priority land uses, those commercial, high-density residential and industrial land uses that generate the most trash load, and then some alternate land uses where jurisdictions may choose to perform a control if they can demonstrate that control of trash on the alternate land uses would produce a greater benefit than control on the priority land uses. The trash module allows inventory of new trash capture BMPs and addressing the trash capture attributes of existing BMPs, and then performing the required field assessments of visual inspection of trash loading. The trash module has a spatial calculation engine that overlays these inventories and land use layers and field inspections, mashes the layers together and summarizes various markers of progress towards reducing trash load to the receiving waters. Here's an example of the online visual trash assessment, the OVTA workflow, where a user walks a transect. The pink markers here show a user in the field capturing a location from their tablet. They can take a photo, walk along the line to the next location, take a photo, record a score. For folks outside of California, the OVTA scores are an A, B, C, or D based on the amount of trash that's visually observed to accumulate, and record those observations. The tool kind of facilitates the first time you visit a site, you'll define your transect. The second time you come to the site, it'll remind you where you walked last time, so you can have a consistent assessment for future visits as you're looking to track trends over time. Then all of this information is summarized into a web-based map where you can view progress through a kind of a high-level manager's dashboard showing the acres in your jurisdiction that have trash capture in place, how much area doesn't need trash capture because it's an A, it scores well in the visual assessment of trash. And then total progress, in this case, the city of Tustin here in this sample is showing 1,400 acres of full trash capture or equivalent out of 2,100 acres that they need to get to. And this allows prioritizing areas where you might need to visit to get closer to that ultimate future full trash capture. So that's a quick overview of the trash module. We can, if we have time at the end and there's curiosity about that, we can do more of the trash module. But what we really wanted to focus on today was the modeling module. Austin's going to talk about this, so I'll let Austin start chiming in and work to keep the slides in sync with Austin.
Yeah, thanks, John. Did my audio come on correctly?
You sound loud and clear.
Great. Hey, so as you said, we're gonna be talking the next few slides about our modeling module, and we're gonna start off with some of the requirements that we had as we set forth to build this system out. So for compliance with our permit, we're really interested in characterizing the long-term expected performance of our BMPs and the load reductions that we can take credit for. We're also required to quantify these benefits for both dry weather conditions and wet weather stormwater conditions. So people are really familiar with stormwater controls, but in this region, we also need to control things during between event periods, that like managing irrigation runoff. That's what dry weather conditions are meant to describe. The system also needs to be fast enough that it can be run on the web. We want these systems to stay in lockstep with our BMP inventory. So when our users change things in the inventory or add a new BMP or refine a delineation, our tool needs to be able to recompute a whole new set of results for that BMP and for perhaps downstream BMPs that would be affected by an upstream change, and do so quickly enough to be responsive for a web tool. So how do we do that for an individual calculation? So here's the obligatory process diagram that webinars like this will always have, but we're going to walk through the calculation here. So the system starts with the set of components that John has already laid out. We've got BMP attributes. We know where these BMPs are situated in our watershed. And by now they've got a delineation, a shape that defines their tributary area. We're going to combine this set of information that Orange County Stormwater Tools manages with the resource we have with Orange County Survey. They manage a set of GIS web services. So by sending our delineation feature into one of these GIS services, we can produce a set of HRUs that describe the land surfaces contained in that delineation. Now, HRU is an acronym, stands for Hydrologic Response Unit. These units tell us information about the slope and the soils and the land use and the imperviousness. And this sort of set of keys, these HRUs, let us relate the land surface to some detailed hydrologic models that we've prepared in the background. So this lets us calculate the dry weather flow rate that's going to come off of this delineation, and to accumulate the stormwater runoff from some calibrated regional modeling that we've done for South Orange County. So after this step, what we have is our establishment of the hydrology of our delineation feature that's going to drain to our BMP. So this information can also be combined with regional monitored information to establish the loading that's going to enter the BMP as well. So our HRUs are really driving the hydrology, and they're driving the loading that our BMPs are going to receive. So now that we've got our loading from our delineation, we can route that through a BMP and transform that volume and that load by the processes that happen in stormwater controls. So for describing our BMPs, we'll leverage the set of attributes that we've recorded in our inventory and bring those forward. But then we'll combine those attributes to scale and size our BMPs according to additional modeling that we've sort of cached in the background here, with long-term capture nomographs for BMPs of various sizes and design features. Our nomographs consider different drawdown times and different BMP volumes at different sets of compartments like media and gravel storage and infiltration. And then we can also use functional curves that are built of local monitoring and of data stored from the International BMP database. And the advantage this gives us is that we can have a robust relationship between a BMP's influent concentration of a particular pollutant of concern and the effluent that we would expect to see from that BMP. And so with these fast lookup tables and functional relationships, we can transform our influent volume into our treated effluent volume for each node, and then move to the next downstream location and repeat the process. So in order to repeat this process in the right order, we've got a regional subbasin network managed by Orange County Survey that covers our entire region of interest of South Orange County with neighborhood scale, 40-acre scale subbasins. And Orange County Survey manages the relationship between these subbasins. So what they're doing is linking one subbasin to the next downstream subbasin. So if we can traverse this list of connected watersheds and solve each feature inside these watersheds in the right order, we can accumulate the benefit in the entire watershed and report those benefits at every node. So one more, there we go. Now we can see how each of these regional subbasins relate and how we can accumulate the load reduction benefit at each node in the watershed and march our way downward toward the ocean. So in the next slide, we're gonna zoom out here and look at the overall architecture and show how it helps us to achieve our quantification of benefits objectives here. So on the left-hand side, we see all the components that change frequently, like editing or adding an inventory item, BMP, or changing a delineation boundary and the associated recomputation of the HRUs needed for us to solve it. And on the right-hand side, we have our modeling input information. These inputs are editable, but are only updated periodically to represent our best available modeling data for our region. So these references are meant to be stable enough to provide a basis for our regulatory compliance reporting. But these two sides working together and communicating via our web protocol, passing the questions formed on the left with the modeling engine to get a result and answer, these two components working together gives us a stable and defensible, easy to manage and always up to date system for reporting our results and presenting them to both our users and ultimately to our to the regulator. So let's go to the next slide. So that that's all great, but what do our users actually need to do in order to get this information reported back? All of that's fairly complicated. So what's the whole realm of information that a user would need to do to get a good result back for a BMP in their inventory? So we have up on the screen, this is actually a snip of the actual site. So to express an infiltration trench, for example, we start with the basics, the name, location, owner, jurisdiction, and a small set of physical attributes. So this infiltration facility really only requires 3 parameters to be entered by the user. In fact, the tool supports over 20 BMP types, and there's only between 2 and 5 required parameters for all of those types in order for us to be able to quantify their benefits with the system we have in place. So once we've got those attributes, we also need that delineation, of course. So the other thing that we have is the user would draw the delineation, and the tool will report to them the land surfaces and the acreages and imperviousness associated with those land surfaces right there on the BMP detail page. But recall, I was talking about HRUs before. These are all sort of saved in the background and referenced by the modeling module in the background, and that complexity is calculated, but it isn't surfaced for the user to have to worry about. And then every 30 minutes, the system will collect all of the changes that have occurred in the previous 30 minutes and recompute the watershed, recompute the whole network to keep the network in sync. And the results of that recomputation are presented on the BMP detail page and are here on the right-hand side, where we have a water balance on the top half and a pollutant load reduction in the bottom half. And we're able to summarize all of our results by wet and dry condition, and of course the overall total. So this brings us to an opportunity to go see what this tool looks like in action. John, am I able to request screen share?
I'm gonna stop sharing my screen so you can start sharing yours. And while Austin's setting that up, so I just stopped. You should be able to ask to share screen now or just take it over. So what Austin just walked through there with the model diagram and showing the asset inventory, that's kind of the main point of pride, I suppose, in this webinar, the title of the webinar being the living model, where if you maintain your asset inventory through the algorithms that Austin has led the design of and Sitka has partnered to implement, you get the results automatically just through maintaining the inventory when other pieces are set up. And I just felt the need to kind of tie that back to the webinar title here, because it's just so exciting. And looking at the details, just wanted to pull back and say that is the living model that we really wanted to emphasize today.
Yeah, thanks, John. So I'm going to do a quick demo. We're going to start with the delineation map with an overview of where our BMPs are in our landscape. And I'm gonna tunnel into a couple of BMP detail pages. We can look and see how their delineations are defined, what parameters were required, and how those results are shown. But I'm not going to be demoing all of the capabilities of Orange County Stormwater tools. And if there's a feature or functionality that was described previously in the presentation that you're hoping to see that we don't get to today, don't forget to contact us, because we can show you each of these pieces. So anyway, let's get started. So I've got up on my screen here the delineation overview map in the inventory module. This is a top level view of all of the facilities in South Orange County, and it shows us how our BMPs are related to the landscape and to each other. So I'm going to zoom in here on a centralized facility, and I'll toggle on those regional subbasins that I mentioned that show us our neighborhood scale. This layer in the black line is managed by OC survey, and recall that these layers point to the next downstream feature. So a centralized BMP situated down here at the bottom of this watershed will treat one or more of these upstream BMPs. And so the centralized delineation is shown in purple for this BMP down here. And these blue BMPs are distributed BMPs. They treat just the adjacent upstream land surface. So let's go look at this one's a vegetated swale BMP. We can see that the user has delineated a region here, a neighborhood street, and the position of the BMP is down here. We've got 3 or so acres and a land use breakdown, predominantly residential and some local road. For this BMP, we actually needed a few more input parameters. I think 4 of these are required: the treatment rate of the BMP, the area, the effective retention depth, and an underlying soil group to get some infiltration here. And now, every half hour, as I said, the system, if this has changed, will recompute it and report our performance here at the bottom. So right now, I've toggled on the wet weather results. So this BMP in stormwater conditions are getting 70% retention. It's pretty good, and is treating and discharging 17% here. So we can see our pollutants of concern are being reduced, and our volume is being treated in wet conditions. The dry conditions with this relatively small upstream area and relatively large BMP means we're capturing and able to retain 100% of our dry weather inflow in this case, which means that as a fraction of our influent loading, we're getting 100% reduction because we're not discharging. And overall, this BMP is doing quite well. We can report this performance on a high level for both dry weather and wet weather conditions. But distributed BMPs aren't the only ones supported in our system. And we've got the ability to treat land areas that are quite a lot larger. And with a centralized BMP, we can take advantage of the fact that there are upstream BMPs, right? And we can get these BMPs to be nested within each other's delineation. So this is the delineation for a low flow diversion situated at the bottom of this sort of watershed, and it's treating 1,300 or so acres with a good mix of land uses. And so a low flow diversion is going to be operated in the summertime to divert dry weather flows to a water treatment facility. So when we look at these results, we expect the performance to be quite good during dry weather. It's sized for the dry weather flow rate, so it's reducing the dry weather flows, and it's not really performing in wet weather. Often these systems are toggled off for wet weather, and they'll bypass during stormwater conditions. We can then, of course, summarize these types of BMPs quite easily. And again, centralized BMPs, the influent to centralized BMPs is already accounting for the effect of upstream BMPs. So our solutions here are nested, and our benefits accumulate. So with that, I would turn it back over to the slideshow, and we can field more questions about the demo at the end. And let's.
Thank you, Austin. I will take the screen share back here, and just on the time check, we're about 10:40 here, and we want to make sure to leave time for some Q&A. So I'll turn it to Eric to just talk through the last couple of slides here and see if we can move through these pretty quick, Eric.
Great. So I'll move through these pretty quickly. I'd like to finish off with just some of our experiences with implementing the tool and kind of moving forward with the development from the Lake Tahoe program. We started in 2018 with the launch of our inventory module. At this point last year, we just launched the trash module and had inventoried roughly 4,000 BMPs in our system. As of today, as Austin just showed, we've rolled out the modeling module, and we've inventoried over 10,000 BMPs, 1,000 project sites, and we've got 20,000 acres managed in the system. Next slide. That being said, we have run into some difficulty because it is such a large and comprehensive tool. It's taken some extra effort to get some of our stakeholders on board and involved in the system. To help kind of ease that transition, we started off with training videos and templates and some webinars, and that did a good job of getting our early adopters on board. As mentioned earlier, we also received some good feedback about how our co-permittees preferred to interface with the system, and we've developed several or some spreadsheet functionality to bulk upload our BMP inventory or assessment records or maintenance records and things of that sort. And we've also developed some Power BI functionality or connections to kind of daylight our data and show the results of all of our hard work. Our biggest success story has been, or from an onboarding perspective, has been our intern project. We hired a team of interns to act as kind of super users and really get in and learn the intricacies of our land development program and OC stormwater tools to help with that data migration process and get our inventory built out. Next slide. So to wrap up, I'd like to quickly touch on our future plans. Our current efforts are really based around finalizing this onboarding process and finishing that stakeholder adoption. As I mentioned, a lot of our inventory was populated using our intern staff. So we're hoping to get more city or permittee assistance using some of their jurisdictional knowledge to finalize our asset inventory. We're also hoping to implement kind of a regulator view to come in and show us some of our data. Without granting full access to the system, we'd like to start showing off some of the results of our work. And similarly, we're gearing up to use this for our upcoming annual report for South Orange County. So we'd like to use our data to demonstrate compliance. And again, we want to start compiling documentation to show exactly what we've done and how we've done and pass that along to anyone else who would like to implement a similar program. Long term, we're looking at developing a planning module. We currently have a lot of good information on how things are working with our existing inventory. So we'd like to develop a way to test out some theoretical or hypothetical BMPs and see what that might do for our water quality. And with that, I'd like to pass it back to John to wrap things up.
Great. Thanks, Eric. That's the end of the formal portion of our presentation today. Some contact information here for Eric, Austin, and myself, and also where if you're on the techier side of things, if you're curious, the source code for the web application, and which we is codenamed Neptune here, or the modeling engine codenamed Nereid, which is a satellite of Neptune, if you're an astronomy nerd, is available, and we encourage any folks to share that if you have an interest in how the software works or interested in contributing or leveraging what's been built here. That is available. So we'll move on to a Q&A session now. And I do have one question in the queue here from Pavitra Ramahan. Thank you, Pavitra. Pavitra asks, what is the process of adding new mixed-use development sites implementing proprietary systems as part of their treatment BMP train within this platform? I'll just put that question onto the screen here so everybody can read that. So Austin, I think maybe Aaron, who's Aaron Pereski with Geosyntec is on the call too, could probably use a little help with this one. So mixed use development sites would be the WQMP or the parcel-based development functionality, and the treatment train component of the question. Aaron, do you or Austin, do you want to take a stab at that?
Part of what Eric and his team have been working on. The component, we would identify the site associated with the parcels in the county's parcel database to establish the spatial location of the site, and then identify the BMPs, add them through the workflow that John showed, and add a delineation to those. And proprietary treatment devices is one of the 20 types that Austin mentioned that are supported. They're a pretty common BMP in Orange County, especially for development projects. And so you would select those. And there's a couple tiers of those and that have the generalized pollutant removal performance. If they were linked in a treatment train with something else, we have thought about that, and we have the ability to, instead of telling a BMP that it has a certain drainage area coming to it, instead link it to an upstream BMP. So say you receive flow from the discharge from this BMP. So for example, a proprietary system then draining to an infiltration tank or something along those lines could be modeled with these discrete elements. So it's a challenge that our users identified, and a very common thing. So the workflows support that well.
Yeah, and I'll also add on to that. That is something fairly common, as Aaron mentioned. As part of our staff and support project, we did wind up interfacing quite a bit with some of the different proprietary system manufacturers, and getting a lot of detailed specifications on exactly how they're working, and figuring out good ways to interface that with the stormwater tools inventory.
So I wonder, any other questions from folks? Feel free to use the Q&A session, or to raise your hand in the panelist window if there's any questions that you might have. While that's happening, I can bring up on the screen here. Log into the platform. So we have a question from Anthony Schutze. Can you describe the general BMP inventory assessment scoring criteria? Does the score automatically decrease annually, and what type of data is required? Yeah, it's a great question, Anthony. So let's take a look at that. So the second part, the score does not automatically decrease annually. The scoring is done in response to the observation. So there's depending on how often you'd like to assess your BMP, if you're going out and assessing it and seeing a material building up or damage to the BMP, that's what would drive the score decrease. There's not kind of an annual degradation component that's built in, although it's an interesting idea, and I could see that being a part of a program design, that if you're not assessing your BMPs because you can't get to them all, you might want to assume some degree of degradation. I'll just find an arbitrary BMP here through this Find a BMP page and click through to view the BMP details. The BMP detail page, Austin showed a little bit of this. Has a field visits panel, and I could come here and should have probably not just picked an arbitrary BMP and made sure that I was finding one that would be interesting, but let's roll with this. To do a field assessment in South Orange County, there's a requirement to do a certain number of dry weather and wet weather visits and post-storm visits. So that's a component that could be customized for particular jurisdictions' requirements. Enter the date of the field visit, And then when you're in the field, this workflow is designed to work well on a tablet. The field visit has several components. Reviewing and updating your inventory. Since you're there in the field, if your inventory is incomplete, you might choose to just take the opportunity to refresh the inventory while you're at the site, or you can skip the inventory part and move on to an assessment. And within the assessment for this particular BMP type, there's a number of observations that you would make. Some of them are pass-fail with the opportunity to add a note, and others, depending on how your BMP is configured, will have a quantitative component, in this case, percent of material that's accumulated. And then the BMP will receive a score based on the weighting that each of these observations has from 1 to 5. So after I have completed, in this case, the field visit workflow is set up with a kind of an initial assessment. And then the expectation is if you're in the field, you may be maintaining the BMP at the time, and then you could conduct a post-maintenance assessment. And that's kind of related to the fact that jurisdictions, permittees don't want to get docked for assessing a BMP that's in poor condition. That's not the intent of most permits, to penalize. The intent is to incentivize maintenance, right? So by supporting both an assessment and a post-maintenance assessment, we're kind of saying it's okay if you go to the BMP and it's full of trash. Maybe you need to be maintaining it more frequently, but what we want to demonstrate to the regulators is not only did you assess it and we're honest about the fact that it had filled up, you maintained it, removed the accumulated sediment. You can record the fact that you were, during this maintenance visit, material was removed. And then you can assess it again and get a higher score. And that's really a positive feedback loop that the permittees and the regulators would want to be able to share within the tool. Question from Dan Ashney here. Is there existing or potential functionality for alternatives analysis or future siting optimization? Yeah, that Dan is the planning module that Eric described in his what's next. So it's absolutely something that's on the product roadmap. And I know Orange County has interest in building that out and funding that component, but we're definitely looking for partners who can leverage the functionality that's been built and may have an interest in expanding on to add these types of future features like alternatives analysis, planning modules, and future siting. I have another question here from Binhong Wu. For volume-based BMPs, such as detention or retention pond, what is the assumption on treatment rate? Do you keep tracking inflow to pond and bypass through based on water levels in the pond? Or or is it just a general assumption? So Austin will take a cut at this one.
Yeah, sure. So our treatment rate nomographs are designed in particular for volume-based BMPs, and they're calculated using long-term continuous simulation. So we actually do a long-term continuous sizing calculation for a wide range of BMP volumes and expected drawdown times. And the reason we key on design drawdown time and BMP volume are those are two things that the client implementing registering a BMP in their system might know about that BMP. So they'll know how it was designed to function. They'll know the volume of it, the shape of it, and some design drawdown time. Or then maybe they know an underlying infiltration rate. And using either a design drawdown time or an underlying infiltration rate, we can use those two data points to enter our functional nomograph curve, which again was derived by doing thousands of runs of BMPs of various size, so that we can come up with a long-term estimate of how much volume, again, over like a 30-year period, that BMP will be expected. And then we perform that calculation using that percentage of capture based on the nomograph calculation. But yes, the volume-based BMPs their long-term performance is calculated based on long-term routed hydrology, based on like local rainfall gauges.
And we do, if there's any other questions, please, I'm happy to stay on for a few minutes if folks had more questions, but in the interest of, oh, I see Anthony Schutze looks like has a question. Damon, could you unmute Anthony? He's got his hand raised in the panelist window while you unmute Anthony, if that's possible. I'll just give my ending slide here, which is that we're really, our model for this technology is of a community of technology sharing. That the license that's on this technology allows anybody to take it and add to it and use it for your own purposes. There's no licensing costs and no vendor lock-in. This is not proprietary. This is community driven, thanks to the vision of the partners in the Lake Tahoe region that Orange County has bought into. So we're very explicitly looking to expand this community and increase the number of folks who benefit from what's already been done and help benefit those who are already here. As the community grows, features become available at a lower cost than if you had to start from scratch, and in some cases at no cost at all if you're able to use, if your program's needs align with the program needs that are already in place. And this is completely customizable. This is not, we're not trying to position this as an off-the-shelf system that meets all of your needs up front, but rather there are core building blocks here that we know have common value across stormwater needs throughout the nation. But there's, if you don't see yourself perfectly in this, that's not a shortcoming of the tool. That's kind of part of this shared development model. So there's a couple of links here where you could go to learn more about this, particularly again, the GitHub repository for the source code, which we just make available to anybody under the terms of the community license, and then the Stormwater Tools service page.
So John, Anthony stated that he was an accidental hand raised, but it looks like you do have a question from Morgan.
Okay, sorry for putting you on the spot there, Anthony. I have a question here from Morgan. I was late into the meeting, but do you differentiate between condition assessment and maintenance priority rating? In standard asset management protocols, the condition score is based on structural physical deterioration and routine maintenance needs, such as trash vegetation, sediment accumulation, that can be assessed with maintenance crews. Condition scores are more construction related, such as concrete pipe replacement, stabilization, major basin reconstruction. So the condition assessment and the maintenance priority rating are not distinguished in the rapid assessment methodology that is used here. The condition assessment in this platform is designed to focus primarily on how the condition affects pollutant load reduction, and less so on kind of the capital replacement aspect of the asset. But if there is a deterioration that is affecting the function of the asset in terms of how it can reduce load or treat volume, that would be captured in the protocol. But this notion of having kind of a distinction between, you know, the construction related failures versus the maintenance priority is not something that's been needed or covered by the current assessment methodology. But I definitely hear and understand the distinction that you're making there, and could see that being valuable, and certainly something that the tool could be expanded to accommodate. So good question, Morgan. And then Morgan notes that they had challenges with drawing that distinction. Yeah, that's one I'd be happy to learn more about and hear what you've learned through that, learning to draw that distinction, Morgan. So if you're open to it, would love to have a follow-up to see what we could learn from your experience there. Okay, well, if there are any other questions, please, I really hope folks would, you know, we'd love for this to be the first step in a continuing conversation if what you've seen is interesting here. Happy to meet with your programs and see, do some mutual learnings in terms of if this community technology could be of interest to you, and to help us identify what we could include on the roadmap to make this more broadly applicable. So thank you all so much for your time, to everybody attended. Thank you to Austin and Aaron with Geosyntec and Eric with Orange County Public Works for presenting on this with Sitka today, and to Damon Knight for facilitating behind the scenes. Thank you and take care.